Hello and welcome to another AES Drilling Fluids TechTip. In this TechTip, we'll talk about drilling fluid solids analysis, and specifically the retort. Retort analysis is the traditional method to perform solids analysis, which provides the oil-water ratio, barite content, low-gravity solids, and other data found on the daily mud report. It is an integral part of any oil or water-based mud check. The retort works by heating a fixed volume of fluid so hot that the liquid phases, oil and water, evaporate. They are then condensed so that you can break out the quantity of oil, water, and solids contained in the drilling fluid. The retort assembly consists of several components. The retort body includes a cup of a fixed volume, usually 10, 20, or 50 milliliters. A larger volume provides better accuracy. The cup holds the drilling fluid sample. The retort body attaches to a condenser that aids to cool liquid vapors into liquid that drops into the graduated receiver. Here is a brief overview of the test. We recommend you review procedures in detail for your own operations. First, the sample cup is filled with drilling fluid as precisely as possible, making sure there is no entrained air. The cap is carefully placed on the cup and a small amount of fluid exits through the hole. Excess is wiped clear and steel wool is placed in the retort body and the cup is screwed to the body. The steel wool acts as a filter to prevent solids to travel further into the assembly as fluid evaporates. The retort body is attached to the condenser and lowered into the heating jacket. A receiver is placed underneath the condenser to capture the fluid. The test begins as the sample is heated and oil and water evaporate and drip into the receiver. After the test, it's time to do some math using measurements from results of this procedure and a few other data points from the mud check. The premise behind the calculation is that with a known volume of drilling fluid, oil, and water, the drilling fluid without the liquid is the amount of solids with the fluid. From there, it is only necessary to determine the ratio between weight material solids and drilled solids. The original mud weight is converted into the mass of equivalent volume in the cup. The mass of oil is converted from the volume of oil and its specific gravity. Because salt is soluble but not present in the liquid phases, the chloride titration is used to account for the volume and mass of brine present in the water. This value is the corrected retort solids. The mass of oil and mass of brine are subtracted from the mass of the mud volume, leaving the mass of solids remaining. The average specific gravity of solids is broken down between weight material and drill solids by using the ratio of their respective specific gravities to provide a volume of each. That is the volumetric method. There is also a gravimetric method, which is more accurate but more practical for lab settings where precision equipment is easily calibrated. The procedure is similar, but you weigh everything. This helps to catch losses due to evaporation or odd performance from a retort. There are efforts to automate solids analysis with new probes and X-ray fluorescence. Many of these tools require special calibration and additional oversight for reliability. Some require calibration with a retort and use the same solids calculations. When comparing data, remember that a retort is most useful with trending. There is an inherent error in the equipment that limits its precision, but it provides a reliable indicator of your drilled solids that can impact performance. There are many assumptions that are required for the calculations, which include specific gravity of your base oil, specific gravity of your drilled solids, and specific gravity of your barite. If two experienced and qualified chemists in two separate labs run a retort, they can get significantly different values if inputs are not correctly entered. Many times, we find that outside party tests use different assumptions for specific gravities, or even test a sample from the wrong pit on the rig. Sharing intermediate measurements and assumptions improves conversations about solids content. That concludes this AES Drilling Fluids TechTip. If you want to learn more, have a listen to our podcast, The Flow Line. If you want to improve your drilling fluid performance, reach out to us at AES Drilling Fluids.